Hi, I'm Nirhoshan. I'm a software engineer in the AI team of WSO2. So today I'll be talking about building trust in generative AI through accuracy evaluation and automation. So these days there are many organizations that are leveraging generative AI to infuse some AI features into their products to enhance the developer experience. But when it comes to an AI feature, key factor would be the accuracy. How accurate are the responses of this AI feature? So from an organization perspective, when a developer pushes some changes to an AI feature, what trust or the guarantee do they have in these changes that is going into the existing AI feature? So they need to, in addition to code reviews and unit testing, for AI features, they will also have to do some accuracy evaluation. And this accuracy evaluation should be automated. So each and every changes that goes into production needs to be checked if a particular accuracy level is maintained for that feature. This process has to be automated such that with each and every PR changes that goes into production, we have verified that it had the accuracy of the feature is maintained at a certain level. So let's dive deep into this. So that is generative AI with and without context. So generative AI, it's being leveraged for its creative responses you can get from the LLMs, which is the large language models. But then there are some limitations to it. It has been pre-trained on multiple different areas and dataset. So the answer it gives might not be tailored for your use case. It might not be, it might be more generic and it might lack some precision since it does not have the relevant context for your particular use case. Then we have this generative AI with context, which will have some context fed into the prompt, and this prompt will be sent it to LLM. So the LLM can look at the context, and based on that context, it can give much more relevant and tailored responses. So this generative AI with context, this is where we are going to try in this presentation. We'll be evaluating the accuracy and the and automate the accuracy evaluation. So one common pattern of generative AI is that generative AI with context is that retrieval-augmented generation, RAG. So this RAG enhances generative AI by integrating some external knowledge sources which will improve the accuracy of the generator. So this has two components. One is the retriever component and the generator component. So there will be a knowledge base created which will contain all the external knowledge sources and documented. So the retriever will use this knowledge base to, whenever it gets a question from the user, it will use the knowledge base to search for relevant context and get the results from the knowledge base and feed it into the prompt. And this prompt with the context will be sent to the next component, which is the generator component. And the generator will generate a response that is more relevant to the user's query. That is the RAG pattern. And let's see how we can evaluate these RAG applications. So there is this Ragas library. So it's a research that has been done and it has defined multiple metrics. But in this presentation, we will look at certain metrics that we will be using for accuracy evaluation. So each of these metrics serve different purpose. So you need to figure out which metric will be best for your RAG application. So the retriever can be evaluated using the metrics like context recall and the context precision. And the generator can be evaluated with the metrics faithfulness and the answer semantic similarity. So both the components will be individually evaluated on different aspects. So before we go into this accuracy evaluation, we'll just be familiarized with some keywords that we'll be using. So one is the question, that is the user's query that is being input into the RAG. And then you have the context. These are the documents that are being retrieved from a knowledge base by the retriever, and then the answer. So this is the generated answer from the generator that for a specific user's question, and the ground truth. So these are the labels or the human annotated answers for a particular question. Look at the context recall metric that evaluates the retriever. So what this metric will measure is the extent to which the retrieved context aligns with the ground truth. So we have a ground truth predefined for a particular question. We want to see that each and every claim made in that ground truth will be available in the context that we are retrieving from the knowledge base. So to achieve high context recall, all the sentences or claims in the ground truth answer should be available in the retrieved context. So the context recall is formulated like number of ground truth sentences that can be attributed to the context divided by the number of sentences in the ground truth. And then we have the context precision. So this will check. So in the context recall, we check if all the relevant context have been retrieved. But now in context precision, we want to see the order of these context that has been retrieved. So we want in context precision, we want the most relevant item to be ranked higher. Because when if there are 100 documents and if we give all these 100 documents into LLM, feed all those 100 documents into LLM, if the most relevant item is in the bottom or in the middle, then LLM might not pick that context to answer the questions. It might hallucinate or give the answer based on a different context. So we want to see if the most relevant context is on the top, it's ranked higher. So that's what we want to achieve by context precision. So together, the context recall and the context precision will check how accurate the retrieval is. So based on these, you can make so many decisions like for the retriever, like how many documents do you want to retrieve? So if you retrieve large number of documents, then the context recall will be higher because there are high chances of getting the relevant documents into the prompt. But then the precision might be low if the rank is not higher. So you might want to re-rank those documents. So based on these metrics, you can like fine tune the indexing strategy. Like based on if the precision is low, you can go and change the indexing strategy of the knowledge base. And then also you can change the search strategy. Like you can, instead of using the distance metric cosine similarity, you can even use Euclidean distance. So, and also you can use re-rank to re-rank these documents retrieved. So there are multiple decisions you can take based on these metrics. And then to evaluate the generator, we have this faithfulness. So this measures the factual consistency of the generated answer against the given context. So if there are any sentences that has been hallucinated, then this faithfulness metric will show us that the answer has been hallucinated. So what it compares is the generated answer with the context. It sees if all the sentences in the generated answer is available in the given context. So the faithfulness score is defined like the number of claims in the generated answer that can be inferred from the given context, divided by the total number of claims in the generated answer. And then also semantic similarity. So we will check through this metric, we will be checking the semantic meaning, if the semantic meaning of the answer matches with the ground truth we have. So what we will be doing here is getting the vectors for the generated answer and the ground truth, and we will compare this through cosine similarity. So this will be the answer semantic similarity. So based on these metrics that measure the accuracy of generator, we can take some decisions like which model to use and what should be the model temperature. So those kind of decisions you can take through these two metrics. So the key stages of accuracy evaluation will dig deeper into this. So the dataset preparation. So that you need to first prepare a comprehensive dataset, and then also you need to do the calculation and get the metrics. We need to compute the metrics, and based on and this metrics computation needs to be integrated into CI/CD pipeline, such that whenever you send some PR, this will automatically run and compute the metrics. And then you need to report the accuracy such that you can make any decisions based on this accuracy reported. So the dataset preparation, this is the very key. This is the key step of accuracy evaluation. So the questions you choose are very important. So the questions should be able to, this data should cover wide variety of complexity. So there should be hard questions, easy questions, medium level questions, and then complex questions, combined questions. Different types of questions should be there such that it can cover all the scenarios that can occur in productions. And also you need to carefully write the ground truth. So these ground truth, if the all these most of these metrics are based on this ground truth. So if you don't have a proper ground truth, then the accuracy evaluated will be meaningless. And also, if you don't have the proper questions, then you are not evaluating the right accuracy. So if you suggest give some easy questions, then you might be confident with the given accuracy that the model might work and the feature might work on easy questions, but we would not have an idea of how it will work when it goes to hard questions. So the dataset preparation is a key step in evaluating the accuracy. And then the metrics computation. So here I have attached a code snippet to evaluate some service. So here we use the Ragas library to get the metrics. So these we want import the metrics which we want. So here I have import context recall, context question, faithfulness, and the answer similarity. So first we get the data set, and this data set we prepare the extended data set by running these questions on the AI feature, and you get the answers and the context. So you concatenate the questions, answers, and the context and the ground truth and create a data set. And that data set will be used in the Ragas library. So this will evaluate the context here. So we mentioned that we want to evaluate based on these metrics. And then the results will be saved to some accuracy results.csv. And also we will, for all the questions, we'll get the weighted mean, and then we will see if we will define some thresholds for each and every metric. So we have to define different thresholds for each metric because each metric serves different purpose. So we see if the threshold passes or not, the threshold passes or not to check if you can pass the total accuracy test or not. So that will be the metrics computation code snippet, and then integrating this into the CI/CD pipeline. So now if you have the code in the GitHub, you can use the GitHub workflows. So you can, for the workflow, you can add a workflow YAML file where you can set up the environment, install the dependencies, and you can set up the GitHub environment variables. You can set it to the variables, GitHub variables, and the secrets. And then you can give the script which you want to run. So here you can give that to run the test accuracy. And then you can publish the accuracy results. So this text accuracy results.csv. Publishing this is also important because if you fail the accuracy test, then you can go and inspect why it has failed. So the report accuracy, so the accuracy results.csv, this is a snippet. This is one example of a row in the accuracy results.csv. So this will contain the whole data set and the context, the precision, context recall, faithfulness, and the answer that is scores you get. So based on this, like you can take important decision. You can decide on what to do next. So if this passes, then you can directly merge this into the production. But if the accuracy test fails, you can come in and look at the CSV file and check which question has failed and which metric has gone down and why it has. You can look at the answer and the context and the ground truth and get an idea why it has failed. So say for instance, for a particular question, there you have retrieved 5 documents, and the most relevant document is not on the top. So the context precision has gone down. And for such cases, what you can do is you can come and you can introduce a re-ranker into the architecture. So then this re-ranker will re-rank these documents and put the most relevant one on the top. So then the context precision will go higher. So that's the accuracy party, and then a bit about the automation pipeline. So how the automation happens. So first, the developer will send a PR, and this PR will trigger the GitHub workflows. And in the workflow, you will have the accuracy script, which will be run to evaluate the accuracy of the changes of the app after the changes. And then based on the accuracy results, you make the decision, you verify if the PR merges, if you can merge this PR or not. So that's the automation pipeline. And some challenges in this approach would be like, so these evaluation results, some of them's metrics use the LLMs. For example, context recall. You want to check if all the ground truth claims are available in the context which you have retrieved. So you use LLM behind the scenario. So the evaluation results are dependent on the LLM. So each time you run it, the results might vary. I mean, by a small amount, of course. Still, this LLM is important. So you might want to use a very accurate LLM, very high accurate LLM. And also, like the data set, as I mentioned earlier, the data should cover all the possible scenarios that might occur in production. So it should not be questions of just one complexity. It should be of different complexity levels. So then only you can get a very good accuracy evaluated. And then you need to create a high quality ground truth data sets. So this creating such ground truths is very time consuming and also expensive. So you need to spend some time and write the proper ground truth for a particular question. And also the LLM API cost. So since you are using the LLM behind the scenario, so for a large scale evaluations, the LLM API cost might be higher. And also there might be performance bottlenecks. It might take some time to compute the accuracy. Also, cost is another factor that you need to include in your budget for accuracy evaluation. So that's about evaluating accuracy of your RAG applications and automating this and making sure that all the changes all the changes that go into the productions maintain a particular accuracy that your organization will persist for user experience. Thank you very much. It's nice talking to you.